Deep within this forest, a silent, invisible killer lingers. We're in the Chernobyl Exclusion Zone, one of the most radioactive places on Earth. In 1986, Reactor 4 of the Chernobyl nuclear power plant exploded, spewing a catastrophic amount of radioactive material into the atmosphere. Thousands died, and an entire region was left uninhabitable for humans. In the aftermath, the radiation was so intense it turned the surrounding pine forest a ghostly red. Soviet authorities, downplaying the disaster, told residents they'd be gone for just 3 days. As they evacuated, they were forced to leave everything behind, including their pets. In the nearby city of Pripyat, a family said a temporary goodbye to their shepherd dog, not knowing they would never see it again. This disaster, a symbol of human failure, accidentally created a massive high-stakes experiment. Can life survive? Can it adapt? Can nature overcome our greatest mistakes? Scientists like biology professor Timothy Mousseau and biologist Kara Love have dedicated their careers to answering these questions. They want to witness evolution in real time, to understand how animals from wolves and deer to the smallest insects are coexisting with their silent companion, radiation. But this companion is deadly. The primary obstacle for life here is the radiation itself. It's a relentless force that tears through living cells, shredding DNA. The immediate effects were brutal. Deer were found suffering from seizures and organ failure. For others, the end came slowly, through chronic radiation sickness. Their blood would pool in their livers and spleens, their immune systems would collapse, and they would die over months. The damage wasn't always hidden. The radiation carved its mark onto the very bodies of the creatures here. Trees grew with twisted, stunted trunks. Spiders spun warped, asymmetrical webs. Birds were born with deformed beaks and crooked tail feathers. Tumors became common. Many animals developed cataracts, their eyes clouding over until they were completely blind, struggling to survive in a world they could no longer see. And it wasn't just the radiation. In a desperate attempt to contain the contamination, Soviet authorities ordered police to shoot all stray pets, fearing they would spread radioactive material. The abandoned dogs, including the descendants of that shepherd from Pripyat, were forced to flee into the highly contaminated red forest, hunted by the very people they once trusted. For decades, scientists pushed through these dangers, trying to piece together the story of life in the zone. But then, in February 2022, a new wall went up. Russian soldiers occupied the exclusion zone. For weeks, the area became a military camp. They ransacked labs, stole equipment, and destroyed years of irreplaceable data. Promising studies were stopped dead in their tracks, perhaps forever. Yet, amid all the destruction and death, something incredible was happening, a revelation. It seemed some organisms weren't just surviving the radiation. They were adapting to it, even thriving in it. Researchers noticed something strange about the tree frogs. In the most contaminated areas, the frogs were pitch black. This dark pigment is melanin, the same compound that protects our skin from the sun. Here it appeared to be acting as a shield against a much more powerful form of radiation. The darker the frog, the more likely it was to survive in the hottest zones. Even more astounding was a discovery made inside the ruins of Reactor 4 itself. A black fungus was found growing, flourishing in one of the most lethally radioactive places on the planet. Studies suggest this fungus isn't just resisting the radiation. It might be asterisk eating asterisk it. Like a plant using sunlight for photosynthesis, this fungus appears to harness gamma radiation as a source of energy, converting death into life. This wasn't an isolated case. In laboratory experiments, scientists took bacteria from Chernobyl soil. When exposed to radiation, these bacteria reproduced better and faster than identical bacteria from clean areas. It was a clear, measurable sign of adaptation, forged in the radioactive fires of the disaster. These discoveries sparked a plan. To truly understand this accelerated evolution, researchers needed more data. Timothy Mousseau and his team set up a network of nearly 100 motion-activated cameras to monitor the zone's elusive wildlife day and night. Meanwhile, biologist Kara Love was focused on the wolves. These apex predators were thriving, but how? They were constantly exposed to cancer-causing radiation, yet their population was stable. Love hypothesized that the wolves had evolved a natural resistance to cancer. Her plan was to capture them, take blood samples, and analyze their DNA to find the protective genes that generations of radiation exposure may have selected for. And the radiation-eating fungus? Scientists dreamed of harnessing its power. Imagine a living shield, a sunscreen against nuclear radiation. It could be used to protect astronauts on long journeys through space, or even help clean up future contaminated sites. But science is rarely straightforward. The plan immediately hit a wall of conflict and skepticism. Many scientists, including Mousseau, argued that claims of rapid evolution were being sensationalized. He pointed out that while the black frogs were fascinating, the link between their color and current radiation levels wasn't strong enough to be conclusive proof of adaptation. The scientific community demanded more rigorous data, more evidence. The debate was fierce. And then came the most devastating blow. The 2022 invasion brought everything to a halt. The military occupation was a catastrophe for the scientific world. Kara Love and her team never got to return to the field. Their Wolf study, which could have held clues to fighting cancer in humans, was over before it truly began. She described it as a bitter blow to our understanding of the world. All the progress, all the potential breakthroughs were buried under the chaos of war. Despite the heartbreak and the setbacks, the work done in Chernobyl was not in vain. The exclusion zone, emptied of people, has unintentionally become one of Europe's largest nature reserves. Bears, lynx, moose, and multiple wolf packs now roam freely. And among them, the descendants of the abandoned pets have formed their own unique population of stray dogs, survivors against all odds. Researchers successfully documented the full, terrifying spectrum of radiation's impact, from the invisible damage to DNA-based pairs to the visible tumors and deformities that scarred the wildlife. And they found real, documented cases of adaptation. The radiation-eating fungus in Reactor 4 is real. The radiation-resistant bacteria, proven in controlled lab conditions, are real. Life, in some forms, was fighting back. What Chernobyl teaches us is that nature is resilient, but it comes at a cost. The disaster created a living laboratory, a stark and constant reminder of how our actions can scar the planet for centuries. The debate over adaptation continues, but one thing is clear: life persists. It finds radical, unexpected ways to survive, even in the face of our worst creations. The story of Chernobyl isn't just about mutation. It's about the enduring, desperate, and sometimes miraculous will to live. It reminds us that protecting our environment isn't just an abstract idea, it is a critical mission for the future of all life on Earth. Thank you so much for watching. If you found this story as fascinating as we did, please consider liking this video and subscribing to our channel for more deep dives into the wonders of our planet. See you next time.